Okay, so we are going to take the time to go over as quickly as possible for all of you here our notes that we took today on velocity and how to solve a velocity story problem. So just give me 1 second here to get my camera going. Thought I had it all set up, but it's not. Here we go. Like I said, I'm going to do a walkthrough here with you just so that these notes go quickly. If, however, you'd like to take the time to actually work through a story problem with me, I do have 2 videos posted for 2 of the practice problems on the worksheet, so you'll get a slower walkthrough with that for those of you that would prefer that. So our notes were on our very first formula, so the velocity, or also known as the speed formula, which you probably have used before, and also how to approach a physics story problem. So what's that thought process that you need in order to solve a physics problem correctly? So first, speed and velocity, they're 2 terms that are used pretty interchangeably, and they can be unless a very important thing is involved with the problem, and that is direction. Speed is the distance you traveled in a period of time. Velocity, however, is the displacement you had in a period of time. So when our speed and velocity are the same thing, we have just a straight line path from one place to another, then they can be used interchangeably, which a lot of physics problems, that's the case. But sometimes it's not. As you know, when we were doing our distance and displacement problems, we would get different numbers if we weren't doing a straight line path. And so because of that, our speed and velocity can be different as well when we don't have a straight line path. So speed is scalar since it goes with distance, and with distance, your location doesn't matter. And velocity is vector because it does matter your location. They both use the same formula. So speed or velocity, depending on what you're solving for, is equal to your distance or your displacement over a period of time. So it's distance for speed, displacement if we're talking about velocity. Both are measured in the unit of a meter. Our time is measured in seconds, and that's represented with the t. And then speed, velocity is measured in meters per second. So these are the symbols, the letters that are the shorthand way to say distance, time, speed. And these are the units it's measured in. So when you have direction listed, it is important to include that within your answer. Now, when we're approaching a story problem, we need to do a few things with our equations. So sometimes our equations are what I like to call plug and chug. So all the numbers are given to you, and it's just a straightforward, hey, solve for speed, so put in a value for distance and time. Other times, though, that's not the case. I might know what the speed is, but I want to find time. Or I might know what the speed is and I want to find distance. So there I'm going to have to rearrange my equation. Now, what we do in physics is just like what we do in math. Math doesn't change. So it's the same thing, even though it might look a little different. So our general rules when it comes to rearranging an equation, you want to do the opposites of what is being done to your unknown. So if you're adding, then you're going to subtract. If you're multiplying, then you're going to divide. And then you want to keep your equations balanced. So what you do on one side of the equation, you do on the other side of the equation. So for this practice problem, I had 5x equals 100. If I'm looking for x, opposite of my unknown, so it's being multiplied, so opposite would be divide. And what I do on this side, I want to do on this side to keep it balanced. So that would give me x equals 20. If my x was on the bottom of a fraction, my first step would be to get rid of the fraction, because fractions are gross. So that's always going to be our first step here. So x on both sides to get x times 10 equals 5. And now I can solve for x. So opposite of multiplication is division. Divide by both sides to keep balance. So divide both sides by 10. So x is 0.5. Then if I had a problem like this, where x was on top of the fraction, again, fractions are gross, so we want to get rid of the fraction first. So opposite of division's multiplication. So multiply 5 on both sides. So I get 5 times 10 is x, or 50 is x. So when we rearrange an equation in physics, it's often good to rearrange the equation before we plug in numbers, because sometimes the numbers are really long and there's a lot of them. So it's a lot easier, it's a lot less work, less steps if we rearrange the equation beforehand. So in physics, we rearrange our symbols. So these are variables that we have and that we're trying to find. So they're the letters that represent a numerical quantity. Now it does matter if the letter is uppercase or lowercase. So notice these are all like a lowercase d and t. So that does matter, because an uppercase t might mean something else than a lowercase t. So our 3 ways we can use our speed formula. If I'm solving for speed or velocity, I just use it as distance over time. It's already set up to solve, so I don't need to do anything. V is already equal to something. If I wanted to find distance or displacement, so I want to get d by itself. D is my x. So right now it's being divided by t, so opposite of division is multiplication. So I would multiply t on both sides to get t times v equals d. Now d, or my x, is alone. If I'm looking for t, this one takes a couple extra steps because fractions are gross and the t is at the bottom of the fraction. So my first step is to bring t to the top. So kind of a nice rule of thumb, whenever you're dealing with one of these fractions, it doesn't matter if you're looking for something on the top or the bottom, always multiply whatever's on the bottom to bring it to the top. So that way you have no fraction. So t on both sides, so I get t times v equals d. Now I can solve for t. T is my x. So I want to get rid of this v here. So divide by v and do that on both sides. So I get distance over velocity would give me my time. Now every now and then you'll see your speed formula with a triangle next to it. So this triangle stands for delta. It's the symbol delta. And what that means is a change in. The change in means you're going to take a final minus an initial. So we use this formula here whenever we're trying to solve for an average. So I have a couple time periods and I want to see what the average speed or velocity that was traveled over that period of time. So these little subscripts here stand for the final minus the initial. So if I want to find the average speed, I take the final distance minus the initial distance over the final time minus the initial time. The units are all the same, so units for the speed, velocity is still meters per second. These are all meters, these are all still time. Now we have steps, ways of thinking when it comes to solving a story problem. So these I like to call the guess steps. The G stands for the given, so what do you have? U is the unknown, what are you looking for? E is the equation, so what equation are you going to use? S stands for sub in your numbers, and then the last S stands for solve. So what is your answer with your unit? So here we have Marcia, who is walking with an average velocity of 0.98 meters per second eastward. It takes her 2,310 seconds to get to the store. What is her displacement? So givens, I'm going to walk through and identify exactly what it is that I have. So I have a velocity here. So I'm told this, some keywords here. So velocity, and then after that is a number. So that's one hint. My other hint, though, is these units, and that's my identifying factor. So if this just said Marcia walks at 0.98 meters per second, so even if it didn't say average velocity, if I saw that meters per second unit, that would tell me that it's a velocity. There's a direction, so I'm going to include that. Takes her 2,310 seconds to get to the store. So notice this doesn't say a time of, but since it has the unit of seconds, I know that's a unit for time. So that's a t value. And I'm looking for a displacement. So these are my givens, symbols, and units. My unknown is displacement, so I can just put a question mark here. My starting formula is speed is equal to distance over time. So if I'm looking for, I'm sorry, in this case it's velocity, so displacement. So since I'm looking for displacement, that's my x. So first step, fractions are gross, get rid of the fraction. So times t on both sides, get t times v equals d. D is by itself now. So now I can sub in my numbers. So 2,310 for t, 0.98 for v. Plug that into my calculator, get 2,263.8 meters per second eastward. And if I'm ready to do this, I want to then round to the appropriate number of significant figures. So my lowest is 2. So I can round this up to 2,300 meters east. So for an average speed problem here, so I have Courtney ran 2,000 meters from her apartment. 20 seconds into her run, she traveled 58 meters, and 80 seconds into her run, she traveled 232 meters. What was her average speed during this time frame? So I have a few more extra numbers here, and I'm looking for an average during a time frame. So that means I need the time frame, and I need her position during that time frame. So even though this says she ran 2,000 meters from her apartment, that has nothing to do with the time frame in which I'm trying to find her average speed. So that's a number that I don't necessarily need to use for this problem. If you wrote it out as a given though, and then later decided that you didn't need it, that's absolutely fine. If anything, I actually prefer that, so then you have all your numbers in front of you. But I'm going to go through and write out these numbers that I have that I need for the problem. And since I have more than one time and distance value, I'm going to assign them initials and finals. So 20 seconds into her run, she went 58 meters. 80 seconds, she went 232 meters. So how do I know which is the initial and which is the final? Well, the nice thing I can do is to first figure out what the initial time is. So to do that, if I hit start on a stopwatch, whatever number would come first, 20 or 80, that's the initial time. So if I hit start on a stopwatch, 20 would come first. So this is the initial time. So then my initial displacement is going to be whatever, or I'm sorry, distance would be whatever the number is that goes with the 20. So in this case, it's the 58. So the initial distance traveled is 58 meters. 80 seconds would be later, so that's the final time. And so what was my position at 80 seconds? I was 232 meters from her apartment. And so I want to know then what was her average speed during this time frame. So with this formula here, it's final minus initials, final minus initials. So and it's all distance on top, all time on the bottom. So final distance minus initial distance over final time minus initial time gives me, if I subtract on top, subtract on the bottom, 174 meters over 60 seconds, or 2.9 meters per second. So if you wanted a walkthrough of a couple problems, especially where I'm going to solve on a little more slower pace, I do have 2 other videos posted attached to this form. But otherwise, good luck with your practice problems. Answers are at the top so you can check your work. And take note those last 2 on the back. I believe it's the last 2. Could be 3, but I think it's just the 2. There's a note there for you as well, but those involve a conversion. So maybe your time is in minutes, so you need to convert it to seconds before you can solve the problem. So just take note of that too. And send me an email if you have any questions. Have a good day.